we have the very humble goal to be the number one climate solver in the world. And to make that a reality, we definitely need to go for parts of India don't have electricity, even parts of Africa. There's a volume jump in the world of available heat just under 100 degrees.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about the massive amounts of energy to be harvested from warm water. Okay, at 90 C or 195 Fahrenheit, for those of us who don't know Celsius, that's still pretty hot. But for making energy where steam is typically generated well above boiling, that's downright chilly. Our guest today says there's this just below boiling resource all around us: manufacturing, commercial operations. In our last episode, we discussed the drawbacks associated with geothermal energy. If the water doesn't have to be that hot, the number of suitable geothermal spots increases exponentially. But there's one sector that will probably surprise you as much as it surprised me. You can find them on the high seas. Yes, ships are an excellent source of hot water. They all have boilers on board after all, and there's nothing out there that can replace the fuel they use to get from port to port. But by harnessing the hot water and using that for electricity as opposed to more fuel, the savings are tremendous. And when you consider that over half the overhead for shipping and cruise industries are fuel costs, those savings add up. Our guest today is Christopher Engman, Chief Revenue and Marketing Officer for Climeon, a Swedish company that specializes in low-temperature heat-to-energy conversion. The company has been operating since 2015 and works in everything from the steel industry to shipping to geothermal. I found out about them when one of their staff searched me on LinkedIn. Glad they did. And as fate would have it, our last episode's guest knew about them when developing their geothermal technology. Remember this?
In the last 2 years, we've been working with a company in Sweden who has come in with a huge forward step in organic Rankine cycle engines. And so where we are getting 250 kilowatts from the water flow that we have with this system we have, they could generate a megawatt.
It's a very small world indeed. Climeon says they cheat the laws of thermodynamics by exchanging heat from near boiling water to a secret liquid that boils at a lower temperature. The equipment also works at lower pressures than traditional power sources, enabling them to get 150 kilowatts out of a small unit that is only about 2 by 2 by 2 meters. The company has received several awards, including the World Wildlife Foundation and Bloomberg, and even has a famous client or two. Richard Branson's Virgin Voyages cruise lines found the company and now has their units on their ocean liners. The billionaire boss even took a few minutes to say some nice things about them.
I've been involved with trying to get breakthroughs on clean energy for a number of years now. When I saw what Climeon was doing, I was very excited. You know, we run on energy, and that energy must turn into clean energy as fast as possible.
Is that cool or what? Christopher and I spoke over the phone. I really appreciated him taking the time to talk, especially when he was on vacation at the time. That was truly a step above, so I hope you enjoy my conversation with Christopher Engman. We're here with Christopher Engman, Chief Revenue and Marketing Officer for Climeon. Christopher, why is there a need for heat power, and how does Climeon technology compare with other energy sources out there?
Yeah, great question. So I think when renewable or sustainable energies are growing in proportion, most of the ones that are mentioned in public media, etc., are solar and wind, and hydro, of course. But solar and wind are intermittent. They deliver the electricity not in a stable way. Sometimes it's on, sometimes it's off, sometimes it's half pace. So to make a complete solution out of solar and wind, you need a substantial amount of storage. And what's very rarely spoken about is that storage, when doing wind, solar, and storage, that total solution is very, very expensive. Whereas heat power, where you extract heat predominantly from the ground, but also water in oil wells, big industrial circuits where they're used to cool down industrial processes, that power is in total cheaper, often between 5-8 cents in total. And it's always on, so you don't need storage in the same sense as you do with solar and wind.
And we've talked about storage a lot, but it would appear that your breakthrough with this technology is your ability to play with the laws of thermodynamics and make electricity from very low temperatures. So explain to folks how that works.
Yeah, so when Climeon was started, there was a gap in the market with high efficiency convert water of temperatures 120 degrees Celsius down to 70 into electricity. There were players there, but their efficiencies were so low that the financials in the end ended up to that level. So our two founders tried to find this spot, and after many years of work, they succeeded in making this work at a very high efficiency. So we have more than 50% higher efficiency than anyone else in that temperature range. We take hot water, and this hot water is going through our machine through a heat exchanger where it's put in contact with the thin layers of metal, put in contact with a liquid that has a much lower boiling point. We don't tell you what the liquid is, but let's say it's an alcohol. And as you know, alcohol is boiling at a lower temperature than water. And once it boils, it expands, and that expanded gas of alcohol is then going towards a turbine, and that turbine is then driving a generator, and the generator is creating electricity. And once the gasified alcohol has passed the turbine, it's cooled down and becomes a liquid again, and then it circulates inside the system. And each power plant is 2 by 2 by 2 meters, so they're pretty compact, and they produce 150 kilowatts each, and you can create clusters of them, much like you do in the IT world, where you bundle many servers into one solution. We do the same.
So it's hot water. So if you're in a situation where the heat is coming from, I guess, ambient air or ambient equipment, is there a way to transfer that heat to your system without it being a water source, or would you convert it to hot water and then run it through your system?
At the moment, we focus entirely on sources where it's already water. There are cases that we're looking at, but you can, of course, take a gas from a cement plant or something, and you make that gas boil water, and that water is then used in the same way. So it's an extra layer of technology in between. But at the moment, in this market that we're looking at is between 5 and 35% of the global electricity market as potential already on the water usage. It's pretty vast. We will, in a few years, start to go also for sources where you only have gas.
Water's where you're at right now.
Yeah, as in any business, you want to go for the low-hanging fruit first, and the low-hanging fruit is where you already have hot water. And there's plenty of those sources, especially under 100 degrees. The closer you get to 90 degrees, the more superior Climeon is as a technology. There's a volume jump when you go just below 100. There's a volume jump in the world of available heat just under 100 degrees.
All that just right below boiling, right?
Exactly. Just below boiling, you have a volume jump that is tremendously large. The addressable market just under 100 degrees is vast. So we don't need to bend our back so much and go for the exhaust gases. We will do that later, but we go for the low-hanging fruit predominantly.
I'm curious about the variables involved. So how much electricity can you make, and what variables allow you to make more?
So we're looking at mainly 3 components. So the flow rate, and the second one is, of course, the temperature of water, and the third one is the ambient temperature, so the temperature in which the location of the heat source is. The ambient temperature is interesting because the difference between the hot source temperature and the ambient temperature, if that gap is bigger, it's an easier task to produce a lot of electricity. So ideally, you have a colder ambient temperature. And also, when you have bigger climate changes like you do in the northern U.S., solar and wind are not as good.
Is there a theoretical temperature floor for how cool a heat source can be for it to make energy? I know you talk about 90 Celsius, but is there...
Well, we go as low as 70, but that has a constraint, which is that the ambient temperature needs to be kind of 10 degrees or lower, a bit closer to 0. So you need to create a big enough delta T. But in practice, what you have on our case is most of the temperatures are 80 degrees up to 120. Very few cases where it's below 80 on the hot source. We also have cases, which I think is a really good one for the future, where you use us. Let's say you have a heat source of 110 degrees Celsius. You use us to bring it down to, let's say, 70. Then you release the 70-degree water into a district heating system where you want the hot water for heating. So the combination of heat, power, and heat is a pretty good one, I think.
And your unit seems smaller. Is there any way to make them larger for more large-scale industrial power production, or is that left to more conventional, say, like combined cycle type equipment? I'm sure you guys have had this conversation internally as a company, right?
Absolutely. There are several motives why we went for smaller units that you can combine in bigger clusters with the software controlling it, and that is economies of scale. In theory, a bigger system will have a better efficiency, but we use a standardized approach, standardized small units that we build big clusters with. We can deploy them a few months after the order and thus start to make money. So a tailor-made system in theory produces a higher efficiency if you have a big heat source. But number one, you produce a new one every time. There's so much project costs around it. Also, the lead time is much longer, whereas we can deploy it in a few months. Time is money. So we do serial production. We don't do customized work, much like in a car factory. And therefore, we can bring down the cost step by step all the time.
And I guess as a follow-up, are there any plans in the future to possibly develop a unit that would be tens of megawatts, similar to a conventional power plant?
No, actually, we do build those with our small units.
Okay. I wanted to get into some of the sectors that you've chosen for this equipment. They're pretty interesting. Explain why large ships are such an attractive market and why there's pressures on these large vessels to become more energy efficient.
So in the world of energy, you have several places where you can see a very clear transformation going from brown to green. On the sea, especially big ships that are going across continents, there's no solution in sight that is transforming sea transportation from burning fossil fuels to completely green. For sea transportation, we only lower their fuel consumption by 5%, but the fuel cost is a pretty substantial part of their total cost structure, and there are many thousand ships in the world.
Well, and depending on whatever an industry's margin is, 5% could be quite a lot.
Exactly.
I wanted to ask you, I was looking through your website, saw some of your videos. One of them featured Richard Branson name-checking Climeon. Apparently your units are used on their Virgin Voyages ocean liners. How did that deal come about, and what was it like working for Richard Branson?
The good thing with Virgin Voyages, the whole Virgin group, and in particular Richard Branson, is that he's sincerely committed to making the world a better place. They actually found us. They saw what we did with another cruise line called Viking Line.
Did you get to meet him?
No, I didn't. So personally, I didn't meet him. Thomas met him. And actually, I joined 2 months after that first deal was made. So I didn't meet Richard Branson himself. But they're really nice to work with, and also the team at Virgin Voyages.
Very exciting stuff. It was very interesting to see him actually talking about it. Oftentimes I think if these guys don't get involved at that level, but that was really exciting.
No, in low-margin industries, the small extra percent here and there on efficiencies can go from making a huge profit to making a huge loss. It's like retail. The efficiencies are making a ton of difference.
Ocean liners are a very sexy industry. I want to get something a little bit less sexy, steel, but no less important. I can certainly see why you're working in the steel industry. It gets hot, and those places use a lot of electricity. How much energy are you conserving at steel plants? I'd have to think it's a lot.
The exact number, I don't know, but we have found most steel plants look fairly similar. We have found 5 use cases in a typical steel plant, and we're at the moment going for one of them, SSAB, so the Swedish steel producer. Steel is great. I mean, they have so much excess heat, and actually, regardless of they use the coal to produce heat or if they move into the electric version, they still have a lot of heat. If you stand next to a newly produced piece of steel, it's beaming heat for, I think it's up to 8 days. That's a tremendous amount of heat. Wherever you're producing raw material, copper, steel, zinc, pulp and paper, cement, etc., the raw material world is a big source of excess heat that you can use for electricity production.
It was interesting that you said you did a steel plant in Sweden, right? There's been a lot of talk about North America and Europe being competitive in the steel industry, all the tariff talk we've heard in the news. Does this help balance some of that inequality with, say, some countries where, I guess, labor costs are lower or maybe energy costs are lower?
Yeah, what you do see, which is part of the competitiveness, you see more and more clients putting pretty high demands on how much energy is used per ton of steel. If you're in an RFP process and you have too much CO2 per ton, then you're actually cut out. So I think on the price level, it doesn't make a ton of a difference, but on the other competitive advantages, it does, like the energy used per ton of steel. Then it makes a big difference. And these companies do a lot to become greener.
And then finally, one of the other industries I wanted to talk about that you guys seem to have been making a lot of headway in is geothermal. I've recently talked a lot about geothermal and have been saying for a long time that this is a resource that's criminally underused. So how does Climeon make geothermal more accessible? I think that's always been the issue, accessibility, right?
Yeah, no, I totally agree. So if you Google geothermal heat power, you'll find that in many of those pictures you see a volcano in the background. Traditional geothermal heat power has been limited to volcanic areas, or at least the tectonic plates. Still, in reports, geothermal heat power can only be used in 150 degrees Celsius and up, whereas we're addressing 120 degrees Celsius and down. The cool thing about that is that we can address all of a sudden places like Eastern Europe, big parts of Canada, much bigger parts of USA than only California, where you find the geysers in those places. Our lower temp geothermal heat power is all of a sudden accessible in many more places. And then there's in geothermal the big new thing that is going on, which is something called engineered geothermal systems, where you actually drill wells with oil drilling techniques. You pour in water, and all of a sudden you have created a geothermal well, but instead of one big well, it's actually a network of small tunnels to heat this water or whatever you're using up, and then you put our type of machine on top of the ground, and you've created all of a sudden a geothermal application without having to look for the water, and that is a game changer.
Yeah, my last episode was actually using oil wells for geothermal energy. There was a professor in North Dakota that worked on it. It's such a random coincidence, but the professor that I was speaking to was talking about your technology in our discussion. As fate would have it, I had reached out to you guys separately without having talked to him, and you're the next interview that I had. So it's such a small world that you two came together that way.
Yeah, no, great. I think I met him. So one of my
with Osnold.
Exactly. Yeah, I met him at Ruben, who's heading up the geothermal attack from our side. They actually held a speech together at the GRC in Salt Lake City last year about low temp.
It's amazing. This is one of the questions I really wanted to get into was, it would seem that your business model is selling your units, but am I wrong? Are there other ways that you're securing an income stream after units are in the field?
Yes, we're selling the power plants with the surrounding equipment sometimes. We do have service and support maintenance agreements. We also have a software piece, a system that is optimizing each power plant and also the subsystems. But then we also have more and more corporations with project financing companies. We even initiated one of them called Basel Capital. Especially in the geothermal heat power cases, we're actually bringing technology and funding. And so it's not only high capex and a low opex, but rather a monthly subscription fee, if you like, with a long contract.
I've always been a big proponent of this idea of selling units and then always having a revenue stream, hopefully, to follow with that, right?
Absolutely.
One of the topics I talk about a lot is that there is this huge need for power in the rest of the world, not just Europe, not just North America. How does Climeon's technology fit into that mix? Africa, parts of Asia, islands, all these places that need energy.
Yeah. So there's only one reason for which we're going for what you would call the industrial world at the moment. It has exclusively to do with certifications. To do what we do, you need to be certified for sometimes countries, sometimes regions. We're also pretty sensitive to corruption. So some countries are actually tricky for us because we really want to stay away from corruption. At the moment, we're going mainly for Canada, US, Europe, and Japan. But we get actually more than one incoming request a day. And if they have a big enough scalability, we have the very humble goal to be the number one climate solver in the world. And to make that a reality, we definitely need to go for, like you mentioned, parts of India don't have electricity, even parts of Africa don't have electricity. It's all a matter of time. We definitely want to do those.
And then finally, technology like this gets a lot of notice and also a lot of awards. Tell us about some of the recognition that you've received.
It's amazing. We have got a lot of those, and we're happy about them. I mean, it's probably not the most well-known thing, but the Swedish Energy Agency, it's not an award, but they have a quote where they said that we're the biggest energy innovation in the last 100 years. Technology is very advanced, but it's not connected to how advanced the technology is, but rather how big impact we can make with it, the big addressable market and the value of being a baseload in the renewable category. Then we were appointed Bloomberg New Energy Pioneer just a few months ago, and WWF gave us the Climate Solver Award, to mention a few. They're great. I mean, that's not how we make money and build a business, but it feels great to get them, and we're very humble about being appointed to those. They're a great extra credibility around the company and for the staff.
Solving the world's energy demands and getting recognized for it. You can't beat it.
Yeah.
And making maybe a little bit of money. Definitely wish you the best of luck with this. And of course, anything that can help geothermal or any source of baseload renewable energy is certainly something I'm a big fan of. I wanted to finish with a lightning round of your thoughts on different energy technologies. And so we'll start with natural gas.
I think it's in the middle of the road when it comes to good or bad. And I think it's a branding that they call it natural gas. I mean, people, they don't understand. They're like, oh, it's natural gas, then it's something good. It is good during the transition, so we'll see more and more liquid natural gas applications, etc.
I think it'll be probably the first time that a lot of people think of natural gas as being a branding term. That's an interesting thought.
It might be provocative, but I stand for it.
Crude oil.
That's on the worst part of the scale. I think heavy oils and coal not only release CO2, they also release particles and other substances that are really bad for the environment. So, no, not very good.
Nuclear.
People tend to think it's cheap. It is actually not. The capex for nuclear is tremendously high, so the levelized cost of electricity is typically very high. During the transition, though, I think you shouldn't cut it out overnight because it's at least not releasing CO2, but I would, like they do in many countries, start to take it down gradually at least.
Coal.
It's the worst. We can stop there. It's the worst. Even the beautiful, clean U.S. coal.
Thank you for that. We do have the beautiful coal. That's what I'll tell you. Wind.
So wind is actually great, and it has an advantage over solar. You can have wind in one town, and the town next to it that has no wind. You can actually transmit the electricity short distances. Solar, on the other hand, you can't send electricity from Saudi Arabia to Sweden in the same region, it's sunny or not.
I think we'll just twin those two together. I think that's the answer for solar. Biofuels.
It's a bit like natural gas. People tend to think about it as something phenomenally great. First of all, it requires a space calculation where we show how little space we need compared to solar and wind. But if you put biomass in it, that space required is even bigger. And biomass is actually releasing CO2, you're burning it. I think maybe in a midterm thing you can use it, but it's not a future solution.
Hydroelectric.
Oh, that's great. I mean, that's the best. It does kind of destroy the nature a bit, but all energy has some kind of negative side. I think hydro, wherever you can use it, use it. You can turn it on and off. You can regulate it up and down. You can use pumped hydro to pump up the water back into the dams and use that as a storage, which is very much needed when you have more and more intermittency in the power grid. So, yeah, hydro is great.
Geothermal.
That's a great one, obviously. I'm biased here. Engineered geothermal systems, that's a game changer.
Electric vehicles.
I think they get criticized for having lithium and cobalt, etc., in the batteries. And also, when you fuel them with electricity, that can be happening in places where electricity comes from fossil fuels. Of course, if you use that electricity to feed your car, you're still using fossil fuels indirectly. But it's a transition. So I think electric cars, you can't wait until everything is green electricity. It all moves at the same time. So I think it's great.
Energy efficiency.
Oh, that is one of the big components in making the world greener.
And then finally, nuclear fusion.
If they get it to work and if the cost can be low, I don't know enough about it. The things I have studied around it might work. But for me, it's like, why should we fiddle around with nuclear at all?
All right. Christopher Ingman, Climeon AB, thank you so much for your time.
Thank you. Thank you, too.
That was Christopher Ingman, Chief Revenue and Chief Marketing Officer for Climeon, a Swedish firm specializing in warm water energy technology. I want to thank him as well as Denise Conway and their CEO Thomas Ostrom for setting this up. All guests are sent the raw and completed audio the week of release. So far, no complaints. You can check out pics of this technology and more at Host Energy on Instagram and online at energy-cast.com. You know, I've been looking at the stats and I cannot believe how many of you download this show each week. Let me know who you are. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 38. Until then, I'm Jay Downhauer. We'll see you next time.